Discover the mysterious voids that devour everything. Journey into the enigma of black holes. So, this mysterious object is like a spot in space where gravity is so incredibly strong that once anything gets too close, it's pulled in and can't escape. It's like a point of no return. Once you go past, there is no coming back. In space, you have different kinds of black holes. The difference might be in how they were created, what is their size, and by their structure. First up, meet the stellar black holes, the rock star of the black hole family. Born from the explosive finale of massive stars, they are several times larger than our own sun. Think of them as the cool kid on the block. Not too big, not too small, just the right size to keep the cosmic rhythm in check. Now, enter the mystery crew, the intermediate black holes. We are still figuring out their backstory, but they are the Goldilocks of the black hole world. Not too tiny, not too massive, just right in the middle. A cosmic enigma waiting to be unraveled. And now, brace yourself for the giants of cosmic skyscape, the supermassive black holes. Imagine a space giant growing and growing over time, devouring stars and merging with other black holes. These behemoths, millions or even billions of times more massive than our own sun, reside at the heart of galaxies, sculpting the cosmic landscape around us. You might be asking, where do they even come from? Black holes won't be just created inside of your room. You have to look into space for stars. Find a massive star. This star undergoes nuclear fusion in its core. Lighter elements like hydrogen are fused into heavier elements through a series of reactions. In more massive stars, the fusion process continues, forming progressively heavier elements such as carbon, oxygen, and up to the iron. This process releases an immense amount of energy, creating the outward pressure that counteracts gravity, maintaining the star's stability. At this point, the star's core can no longer sustain the outward pressure needed to counterbalance gravity. The collapse of the star's core triggers an explosive supernova event. During the supernova, temperatures and pressure reach extremes, enabling the formation of even heavier elements through rapid nucleosynthesis. Elements beyond iron, like gold and uranium, are forged in the intense heat and pressure of supernova. In the aftermath, the remaining core may either become a neutron star or, with sufficient mass, collapse further into a black hole. The intense gravitational field of a black hole is a consequence of the concentration of mass within an infinitely small space, creating a gravitational pull so strong that not even light can escape the grasp. So, the remnants of the massive stars give birth to the most extreme gravitational phenomena in the universe. Now that we have black hole created, let's see what it's made out of. At the heart of black hole lies the singularity, an infinitely dense point where the mass of the collapsed star is concentrated. The laws of physics, as we know them, break down at this point, and our understanding of space and time becomes elusive. Surrounding the singularity is the event horizon, an invisible boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. Once an object crosses this threshold, it is on an irreversible journey toward the singularity. Additionally, many black holes exhibit an accretion disk, a swirling ring of gas and another matter. As material from the disk spirals towards the black hole, it becomes superheated, emitting intense radiation. This phenomenon is one of the ways astronomers detect and study black holes indirectly, as the accretion disk's radiation is observable. Now, the question you've been waiting for: what would happen if you were to get closer to a black hole? The first thing what will happen is that you will experience spaghettification. It means the gravitational pull will stretch you. You would keep stretching until your body won't be able to handle the pressure and split. Next thing what will happen, thanks to the gravity again, is that you will be in such big amount of gravitational force that you will start to fall apart. First your skin, the muscles, organs, until the only thing what's left is your skeleton. Of course, it will depend on the size of a black hole. Now, go back to your room. Look in the telescope. You might be asking, why do we only see this blurred ring? The reason we see the blurred ring often refers to as a shadow of a black hole, rather than the central singularity itself. It's due to the profound warping of space around the black hole. The event horizon, the invisible boundary beyond which nothing can escape the black hole's gravitational pull, acts like a one-way membrane for light. Once light crosses the event horizon, it is inexorably drawn toward the singularity. As a result, any light emitted or reflected from the region inside the event horizon cannot reach an external observer. So, to put it simply, the center of black hole can reflect the light because it has been absorbed by its gravitational pull. The ring we see is only the disk of black hole. This part is made out of hot gas which emits radiation. Thanks to special telescope, we can detect this radiation and visualize it in the photo. Every masterpiece must once end. Black holes can undergo various processes that influence their fate. One notable theoretical mechanism is Hawking radiation, proposed by Stephen Hawking. According to this concept, black holes gradually emit minuscule particles due to the quantum effect near the event horizon. Over an immensely long timescale, this radiation can lead to the evaporating of black hole. Another scenario involves the merger of black holes. When two black holes are in close proximity, their gravitational interaction can cause them to spiral towards each other and eventually merge into a larger black hole. This process releases gravitational waves, which were first directly detected in 2015. Providing observational evidence of such mergers. Here's the sound what has been captured. Even with their menacing aura, black holes contribute to the cosmic narrative, shaping galaxies and playing an indispensable role in the evolution of the universe.